In order to become a better programmer in R, I would encourage you to think a little bit about what's actually happening when you do an assignment of a value to a variable. So if I assign the value 2 to x, then I look at the value of x in the console, I'll see that it indeed has the value of 2, but I'll also see this 1 in square bracket that's actually telling me a little bit more about the data structure. Let's talk about a little bit about what that data structure is. So ultimately, when you assign a value to a variable, the runtime engine in R has to know the type or class of the object it's assigning to the variable to know how much space it's going to take up in the RAM. Now notice that we didn't tell it what type the variable was, we just assigned a value 2 to it. And that means that how R operates is it's going to assume a type based on the value that you're assigning to the variable. So R sees that number 2 and it just guesses, well, I'm thinking that they want to put a numeric value, so I should probably assign a numeric data type to this in order to save it. Now this is what's called a non-declarative language, meaning you don't have to declare the types of variables. And it's very convenient for fast coding, but it's also a little bit dangerous in that you're not explicitly telling the computer what the data type is of the variable. That means you just have to know what the data type is. And that means when you're programming in R, you better be able to explore what kind of data type is to make sure it's what you expect it is. Now in R, the smallest or the most basic irreducible data type is what's called an atomic vector. So you can't really make anything more basic or smaller than an atomic vector. And that's going to be a vector of a given atomic type. And by atomic type, I mean there's 4 typical data types that you're going to find in just about any programming language. And that's the type you need for storing real numbers. And double is short for double floating point values. And that's how we keep track of real numbers in R. It could be an integer numeric type, so the counting numbers. It could be a logical data type, that would be the trues or falses or zeros or ones. Or it could be a character string data type. Now it's important to note that these are all vectors. So the smallest data type is not just a single value in R, it's a vector of values that could have 0 or more values to them. So the most fundamental data type in R is already a vector, meaning it could have values in it with indices going all the way from 0, 1, 2, 3 up to however many you need for that vector. So in this case, if we're talking about an atomic vector of type double, then we're going to have spots in memory that are numbered according to these indices, 1, 2, 3, etc., up to n, and the contents of each one of those spots in memory is going to be some real number that we want to keep track of. So that really explains this 1 in square brackets. It's telling us something about the index of the value that we're seeing when we type in the variable name in the console. So there's a single real number that we've assigned to x, the number 2, and that means we have a vector with just one element in it, and this is telling us that the element index for the value 2 is 1. That's the 1 in square brackets. So ultimately, I would encourage you to always double check you know the data type you're dealing with in R, because sometimes you can't really tell just from the assignment operator. And the way you do that with the suite of functions. The root function for doing that is the type of function. This tells you the fundamental data type in R of what you're dealing with. So if we go back to our console and we do a type of on X, it's going to tell us it is a double floating point data type atomic vector, which means it's 0 or more real numbers is what we're storing here. And in this case, we are storing just one value. With the understanding that an atomic vector can hold more than one value, let's go through a few examples of ways to create vectors that have more than one value in them. One of those ways is using the C function, which I believe is short for combine. It's a very generic function for combining values together, and R will try to make the simplest data structure it can from what you're trying to combine. So if I do an X assignment, I'm assigning the X variable, what comes back from the C function, and I can just give it an arbitrary list of values. For example, 2, 5, 12, 34. And it will put these together in the simplest way. And since these are all numbers and the same type, R is going to say, well, I think they probably want a numeric data type. And I'll create a vector with these 3 values. So if I look at X, I can see that it has 4 different values, 2, 5, 12, and 34. And again, that 1 in square brackets there, that's the index of the first value in this line. I can also look up here in the upper right and see that RStudio's graphical interface is going to tell me the variable X has a vector, a numeric vector, that's the NUM, values 2, 5, 12, and 34. And here it tells me that there are 4 elements. 1:4 is describing the number of indices for this particular vector. In computer programming, it's common to want to create a vector of numbers at regular intervals, and in particular, integers. So one quick way to do that in R is with the colon operator. So if I say X is assigned to the values of 2 to 20, that colon operator is going to automatically create a bunch of numbers between 2 and 20, and assuming that I'm starting with integers, it's going to space them according to an integer value. So it'll be 2, 3, 4, etc., all the way up to 20. So if I look at X after creating that, I will see I have the values 2 up to 20. And I can do that with as many values as I want. So let's say I want to go 2 to 200. Now I have 200 values in X. If I look at X, I can see all 200 of those values. So I have 2, 3, 4, 5, etc., all the way up to 198, 199, 200. Now note, now that I'm going to several different lines in my output from putting in X, that I have more square brackets here. And again, that's telling me something about the indices of these values. So the value 2 is the first element of this vector. Therefore, it has the index 1. The value 22 has the index 21 because this index is indicating the index of the first value on this line. 42 has the index 41. The value 42 has the index 41. The value 62 has the index 61. 82, 81, etc., all the way up to the value 182 as the index 181. Now recall that we can look at the type of a given vector using the type of function. So I want to do a type of on X to see what the data type is. And here you'll see we see something different. It doesn't say double. So again, R is making an assumption about the data type that we want to create. And when you use the colon operator and the starting and ending values are both integers, R is going to make the assumption that you want to create an atomic vector of the integer data type, meaning all of the numbers are going to be whole numbers like these. So this is just an example of how you have to be very careful in R because an integer is going to perform a little bit differently than a double when you do math with it. And you want to be careful with that. So you want to know the data type that you're creating. Finally, there's one more way to create sequences, and that's with the seq, or I call that the seek function. So I want to create a sequence of values. And there's lots of different ways to use sync, but a pretty common way is to give it the argument from, which tells it a starting value. So I'm going to put in 2 here. And I'm going to put in a 2 value, which means what's the ending value you want to go to is 200. And you can tell it how big to make the intervals using the by argument. So I'm going to give the by argument the value 1. So this is basically the same thing as the colon operator. I'm starting at 2. I want to go to 200 as the top value, and I want to increment the value by 1. So I've created that. I can hit X. And notice it doesn't look any different, right? I still have whole value 2. I still have whole value 200. I have the same indices. It looks exactly the same as when I used the colon to create the vector. But if I do a type of on the results of the seek function, notice it's not the same data type. It's a double floating point number. So these are not the same data point, which meaning there's some ways with some functions and some operators, well, these are going to perform differently or behave differently than they would if they were integers. So those are just a couple of things to keep in mind that you need to be careful with in R in terms of data typing. And it also gives you an example of another way to create sequences. Now the sequence function is a little bit more flexible in that it lets you create sequences in lots of different ways. I'm going to do a help on the seq function. And you can see you can give it a from and a to argument, and you can give it a by argument to set the size of the interval. But instead of the by argument, you can also give it a length out argument. So if I do an x equals a sequence of values, the seq function from equals 2 equals 200, and say I don't care so much about what the interval is as long as it's regular, and what I really want to control is how big the vector is that's created by this. So let's say I want to create 50 evenly spaced intervals between 2 and 200. Oops, I mistyped. I missed equal sign instead of that minus sign. Now I have values. The lowest value is 2, the highest value is 200, and these intervals are whatever they need to be regularly spaced such that I have 50 values in this vector. And you can see the value 200 is the last element, and it has the index 50 as I specified here. So that gives us 3 quick ways to create atomic vectors. I can use the C function to create an arbitrary atomic vector just based on a list of values that I give it. Note if they are not the same type, R is going to force to the most abstract type, and I'll give you an example of that in a little bit. We can use the colon operator from value and to value on either side of the colon, and this is typically done to create a quick vector of integers. Or more flexibly, we can use the seq function to create lots of different regular sequences, and we have lots of different arguments in the seq function that we haven't even touched yet. So there's lots of different ways to create a vector with the seq function.